Hello, everybody. My name is Joel Reed. I'm the Executive Director of the Pittsburgh Robotics Network. We thank everybody for joining us now this afternoon on the East Coast, and good morning to those on the West Coast and other time zones. We're going to wait just a few moments to allow everybody to come in and get settled in. So give us just a moment. All right, this is always the awkward silence. We've got folks that are just joining us. We'll wait another 30 seconds here and we will get started shortly. I want to thank everybody for joining us today. Okay, probably a good time to get started. So again, thank you everybody for joining us for today's webinar, hosted by the Pittsburgh Robotics Network and sponsored by SKA Custom Robots and Machines. Again, my name is Joel Reed. I'm the Executive Director of the Pittsburgh Robotics Network. So we exist to connect you with the Pittsburgh robotics community, which is one of the largest and most important in the world. The PRN was founded in 2016, but this year, with a strategic plan and financial support, the PRN is expanding. It's our mission to bridge a very large and dynamic community to worldwide industry networks by promoting our community as the leaders that they are. We will work to make strategic connections, expand our collective knowledge, and positively influence the development and adoption of robotic and artificial technologies. Before we start, I would like to recognize our sponsors. Our community is coming together to help advance our efforts and to support the mission of the PRN. First, I'd like to recognize one of our early sponsors, Carnegie Mellon University, which many of you know is the world's leading institution for AI and robotics education, research, and development. Argo AI has also signed on as a founding sponsor. And Argo, if you're not aware of it, is one of the world's leading autonomous driving technology companies, which was founded by CMU alumni and veterans of the CMU Tartan racing team, which won the Urban Grand Challenge and launched the self-driving industry. Also, a founding sponsor is RE Squared Robotics. And joining us today is Jorgen Petersen. Thank you, Jorgen. RE Squared is a leading developer of mobile manipulation systems, which creates interoperable manipulation systems with human-like performance to perform difficult jobs for exploration, inspection, and applications. And then finally, we have Carta as a founding sponsor that leverages scanning and sensor technology to capture the world outside. This bridges the physical world with a 3D digital twin for applications across architectural, geospatial, and autonomous robotics applications. We have sustaining sponsors, Dentons, a multinational law firm, which is the 5th largest worldwide, that came to Pittsburgh with the acquisition of Cohen & Grigsby, one of the world's leaders in robotics commercial legal representation. And then finally, Omnicell. Founded here in Pittsburgh from the original automated healthcare, which had spun out of CMU, Omnicell provides innovative pharmacy and medication management solutions for healthcare professionals and health systems leveraging autonomous systems. Today's event is sponsored by SKA Solutions, which is a fast-moving and solution-oriented engineering, consulting, and contracting firm. And courtesy of them, in addition to sponsoring and moderating today's panel, they will be providing a giveaway. So there will be a link in the chat provided by Jen Apicella of the PRN. Please take a look at that and fill out this prize form. At the end of the event, we will make an announcement of the winner. So be sure to stick around if you can, but be sure to complete this form. Of course, one of our main pillars as an organization is to create better connections within and beyond the community. So we encourage you to follow us. You can visit us at our website at robopgh.org and follow us on Twitter and LinkedIn. And those links are being provided in the chat as well. Before we get started, I would like to tell you about the next event that the PRN is going to be holding. I encourage you to check it out and join us next month, where we will be featuring Jim Rock, CEO of Seagrid, which is a category leader for autonomous mobile robot solutions, or AMRs. This event is sponsored by BEA, which is an industry leader in sensing solutions, and will be moderated by Tim Chipetta. So that's it for me. The more exciting part is to come. Let's go ahead and get started. I'd like to introduce our moderator, Spencer Krause. Spencer is the Director of Product Development at SKA, Custom Robots and Machines. There's a link to their website. Please do go check them out. He's working with a number of companies, not only in Pittsburgh, but nationally and worldwide. Spencer has a master's degree in robotic systems development from Carnegie Mellon University. And he also records a podcast, which I was honored to be a part of and be a guest for yesterday. And that should be published in the coming weeks. So that was a lot of fun and it was really good. And it's great to be getting to know Spencer. So Spencer, thank you very much for moderating today's panel. I'm looking forward to the discussion.
Joel, thanks so much for having me. And I want to also thank our panelists here and Jen for playing a big part in orchestrating this event. You guys have been amazing to work with, and this has just been a real pleasure all around. So you guys all came here to see some really accomplished field roboticists talk about their work in the field. So we've got Jeremy Searock from Advanced Construction Robotics, Jorgen Petersen from RE Squared, and Vaibhav Vohra from Gecko Robotics. All these people are accomplishing incredible things in the field today, and I'm not going to embarrass myself by trying to say what they do better than they do. So Vaibhav, why don't you get us started by talking a little bit about your background and the types of field environments your robots operate in?
Sure. By the way, thank you for having me. It's been a great opportunity. So yeah, my name is Vaibhav. So here I've had experience working at several different Pittsburgh-based companies, one of which is Bossa Nova, which did retail robotics. And here right now I'm at Gecko Robotics. And what we do is essentially bring robots to life-saving applications in oil and gas, pulp and paper, and power industries, where we do inspections of very difficult assets. And we also collect data as part of our platform. So we bring robots and the power of data together to make it safer for people to not have to go into those dangerous environments.
Excellent, thank you. Jorgen, you want to jump in?
Sure. So at RE Squared, we develop intelligent mobile manipulation systems that empower humans to do their jobs safely and efficiently. You can really think of it as robotic arms on mobile platforms that replicate human capability, both from a physical and a cognitive perspective. And when you look at the physical, our robotic arms, which are called RE2 Sapien, they need to go anywhere on the planet, which is, a big theme I think we'll see today. And, whether that's indoors in an operating room, helping surgeons do their job better, in the mountains of Afghanistan, helping to keep people away from danger, or under the sea level of the Pacific Ocean, helping to do inspection underwater. That's where our arms go. They go anywhere on the planet. They go where people go. And I suspect we're going to see a common theme today when you look at outdoor mobile robotics. There's a new level of complexity that goes beyond the factory floor. And in turn, there has to be a whole nother level of rigor that's applied when you look at the design and testing of these products. So I'm really looking forward to the conversation and getting into it. So thank you.
Thanks, Jorgen. Jeremy, why don't you tell us a bit about what you do at Advanced Construction Robotics?
Sure. Thanks, Spencer, and thanks to the Pittsburgh Robotics Network for hosting this webinar. It should be a lot of fun. So I'm Jeremy Searock. Previously I worked at Carnegie Mellon and graduated from Carnegie Mellon and did a little bit of a time as a submarine officer in the Navy as well. But in 2016, we founded Advanced Construction Robotics around bringing robotics and artificial intelligence to the construction industry, which is a very large industry and currently has some significant problems around skilled labor shortages as well as productivity rates. Historically, the industry has not adopted technology and has a great gap available for this type of technology to have a big impact. So specifically, we started to work within the heavy civil side of construction. I founded this company along with Stephen Muck, who's also the CEO and chairman of Bremen Construction Corporation, which is a heavy civil contractor here in the Pittsburgh region. And our vision really is to decrease the cost of infrastructure through the use of robotics. And specifically, we're going to make robots that work at the job site. As you can imagine, we're used to using robots inside of a manufacturing facility, which is a controlled environment. And as the theme is for this particular podcast, our robots need to work every day on a changing construction site. So specifically, our first products are in the bridge construction side, and the designs of bridges changes, the sizes change, the rebar configurations change, and our software and our robot needs to adapt on the fly. And as you could expect, customers expect it to be a product, not an experiment. So you have to, you can't fake it. It has to work every day.
Excellent, thank you. And Jeremy, I think you did a really good job segueing us into this next question here, which is I'm going to posit by the other panelists, which is there's sort of two competing schools of thought here. And one is, you should perform research first, develop a technology, and then find a fit at market. And another one is, you should find a fit at market and then develop technology to match. And so, Vaibhav, I'd like to ask you, which approach did Gecko take, and kind of how did you find your voice there?
Yeah, I think we definitely found a problem for which we found the problem first. That was, people going into these dangerous areas, and they had a hard time, finding reliable ways to inspect some of these assets. And so we definitely focused on what are the best solutions that could help reduce cost and save lives. And I think we came from that problem into a solution space of robots. So it was a little bit more like the problem leading the solution, as like the or no way to go about it. I think that oftentimes, that we added other things that are non-robotic in terms of other technologies to add on to it. But I think for us, it was definitely the problem leading, the application.
It's a great approach and one I'm a big fan of. Jorgen, how about you?
And so we added an interesting start. We started off as a contract engineering company that was, you could really view us as an extension of Carnegie Mellon University. And then in 2006, we received a Small Business Innovation Research Grant, or SBIR, that which brings to you a problem and a customer and non-dilutive funding. So that's what really set our path into creating these intelligent mobile manipulators. And that's what we do today, all as a result of that first SBIR. But I'm not saying I'm advocating that everyone goes that route. We bootstrapped the business over 20 years, which requires a lot of patience and requires going after kind of blue ocean opportunities. In today's day, I see, things move much faster. So if there's still blue ocean, you could consider bootstrapping and incrementally creating a technology over time. But I would strongly advise to anyone who's starting up a business, find the problem, find the need, understand what the market pull is, and then optimize a solution to solve that problem. Any time that you have a solution looking for a problem, it's not always the best recipe. So now that said, there are times where, in a business like ours, where we make a generic capability, which are robotic arms that can operate outside. And that can have multiple use cases and multiple applications. So once you have that initial customer and you're solving that additional need, then you can start expanding and looking, how else can I modify my technology to open up new application areas, new application development. But not everyone can do that. So my strong recommendation is always understand where's the market need, where's the market pull, and optimize a solution for that.
I couldn't agree more. Thank you, Jorgen. So I guess the reason everybody came here today was to hear some interesting stories from the field. And a great Italian philosopher once said, nothing great was ever achieved without risk. So I'm going to kind of kick it off with one of our stories, and then I'll open the panel up to Jeremy first and then the other panelists. So we've all have stringent quality assurance practices, but as you know, things don't always go as planned in the R&D space. SK sponsored an event in Q4 of last year where we featured a course that people over the internet could drive our robots through. So it was sort of an industrial inspection, James Cameron-esque, nightmare scenario, and you were meant to drive a robot through it and identify threats to human life. Well, one of our robots malfunctioned in a tunnel that was particularly difficult to access, and everybody that worked on the set really hated working in there, which made it great for robotics, right? And so, I mean, it got our point across, but at the same time, I had to remove my suit during the event and shimmy down, sandpaper, basically, lacerating my back up. In the process, it took about 15 minutes to diagnose the fault. And it turns out what it was a bolt had shooken loose because a junior technician hadn't really gotten the memo on using Loctite to put down all fasteners. But luckily, the person driving the robot, they were an engineer in robotics at a Fortune 500. But they were a robotics engineer. So I get it. These things happen all the time, and it went fine. But it could have been a lot worse if it hadn't been somebody with field experience. So I guess that was kind of a mistake, a lesson learned in our end, and just something kind of a little bit amusing there. Jeremy, do you got a story like that?
Yeah, I have lots of stories, but I will focus first sort of on a serious note before the funny story. But we call ourselves robotics companies, but we are also normal companies in the sense that, for example, us with our Tybots, we already have a fleet of robots, a rental fleet that's transported around the country doing jobs every day. So if you're in that realm of managing a rental fleet, stuff's going to happen all the time. Things can break in transit, things can break in the field. So it's very important for robotics companies to not just think about the technology, but to think about the other supporting departments that support that technology. Which for me, we have a service department, so we have a great service manager, and we have a fleet of, or a staff of technicians who go out with the robot to make sure it works every day. So that's sort of the one aspect, is things are going to break, but you have to think about the staff that supports that, because the customer, right, is expecting it to work every day, and you need to be prepared to pull that off. That said, is you can't anticipate everything, which you try to do as a roboticist, right? You're writing your software to try to anticipate everything that comes down the line. So one recent example is we were on a job, and it happened to be directly under some very high voltage power lines, and we didn't anticipate the sheer amount of static load that would be created by some very close, very high power lines, causing arcing going through a particular system. But thankfully, we had a technician staff and our field support staff who very quickly could deploy within 24 hours and mitigate and add a grounding strap to take care of the situation. So you can't anticipate it, but we were able to finish the job and do a good job based off of that support we have.
Thanks, Jeremy, and certainly been there with the high frequency power causing signal disruptions. That's a bear of a situation for sure. And you're absolutely right, by the way. had our approach been for a client, it would have been a different story with the level of technician we had on the project. All right, Vaibhav, why don't you tell us one of yours?
Sure. And by the way, apologies if my connection is breaking up. Can you guys hear me still?
Yeah, you're coming through loud and clear.
Perfect. Yeah, I think the story that I want to tell is the role of design and how it plays into robotics, especially for consumer-facing applications in industries like retail, CPG, even like industrials where there's a fair degree of interacting with humans. When we first saw the initial designs, both within our competitive landscape as well as ourselves, some of the robots were really designed to interact and for people to get closer to the robot. We didn't want people to be afraid from them. And so in some cases, kids would actually run and hug them, which is a great experience, right? That kids, aren't afraid of robots, that they're interacting with them, they're safe. I think what we quickly found is that actually ended up impacting our ability for the robot to perform its mission, right? Which is kind of the dual-edged sword of designing for customer experience and a pleasurable experience, but also, what role does it have in being, essentially being very workman-like and accomplishing what it's supposed to. So that's kind of an interesting, way of looking at it, of like, try to give the robot human qualities versus allowing it to be, very, very work oriented. And I think that like what we found was like over time that, that there should be, robots in general, we want people to accept them. We want people to understand them. It should be very obvious what it's trying to do and how you should be interacting or being careful with it. But I think that the most interesting thing is we found that the last mile of personalizing the robot, like whether it's giving the robot a name tag for a retail setting or giving it like, some name of a local team, right? Like the role that could play in the overall adoption and understanding of people that have to interact with it. So this concept of human robotic interaction and how crucial that is to get right was one of the really interesting lessons that I've learned.
That's a really fun angle. I appreciate that, Vaibhav. Thank you for bringing that in. Jorgen, why don't you take the wheel for a little bit?
And so when I've been doing robotics for over a quarter century now, so you collect a lot of stories. The good news is most of them are early on, which means that we're learning as we go. I don't really have any recent stories, which is the good thing, right? Most of my more entertaining stories are back earlier in my career, where you do learn those lessons and you learn them fast. Just to call out one, we were working on a DARPA program where we were asked to make an ATV drive in any biome and autonomously navigate. And we were out in the desert driving along the edge of a really steep hill. And back in the mid 2000s, the software that determines the difference between a rock and a bush wasn't quite as elegant as it is today, or sophisticated as is today. And I still remember that safety operator with the big red button driving behind the robot as it's trying to figure out how to navigate through a desert. And I still remember him saying, "I got it. No, it's fine. I got it." And the next thing you know, the robot sees a bush, thinks it's a rock, turns hard right instead of turning hard left, and goes end over end and over end down the hill. Now it landed on its feet. Luckily, we had a good roll cage on it, and a couple sick lidars took some damage at the time. But it was a wake-up call, right? Luckily no one was hurt, right? And that was the lesson learned, is that these things are out in the real world, and the real world is complex, it's unstructured, it's unpredictable, especially if you throw humans into the mix. So that was a really good lesson to learn early in my career, to focus on making sure that in our business, we have a significant effort focused on safety and focused on quality. And there's another level of rigor that's required in the design and development process when you're dealing with field robotics, because they're out in the real world, right? They're not caged off and isolated from people like oftentimes they are in manufacturing plants. So a lot more thought and processes to be put in, and now we have a director of quality management. We have a safety committee that's just looking at safety throughout the business. And these are key lessons to learn early on, especially if you're going to talk about robots out in the real world.
Thanks, Jorgen. Those are some really good takeaways, and that's an incredible story. I don't think anyone could hear me laughing, but there were some great high points in that. So thanks. All right. So is there anything else anyone else wants to go into to elaborate a bit on some of the lessons learned from the stories here? I know we have a little bit more time than expected. We're kind of a little bit under, but I've been told not to emphasize challenges too severely. So, we can kind of stick to the script here.
I could jump in with another
Sure.
thought. So we make robotic arms, so they're used in many different use cases all over the world. And as if you're looking at robotics to be deployed as products anywhere on the globe, there's a lot you have to think about. And one of our most challenging products that we had to ship was we took one of our two-arm systems and we shipped it to Fukushima. And they mounted it. So first of all, it was designed to be mounted right side up, to be in non-radiological environments. And we had just we at that point we had just set up our RMA system and all the support needed to have product out in the field. But we took a risk and we said, all right, well, let's ship this because it's a good cause. Let's help with the cleanup of the nuclear disaster. So they mounted it upside down. First we did the engineering analysis to make sure that it could survive. We shipped it halfway across the globe. We did our analysis. Hey, we think it's going to survive a radiological environment, but not quite sure how long it's going to survive. So we shipped it and delivered it. It was working well. But the level of rigor that we applied is what allowed it to work well. Now, a month in, one of the components went bad, not on the radiological side, but at the operator interface side. And it was easy. All we had to do was ship them a replacement part, and then they shipped us back the failed part because it wasn't in the radiological environment. But it's going back to what Jeremy was saying about making sure that you have all the infrastructure set up to support product in the field. It's not just an R&D. You ship out a prototype and hope that it works, and you just deal on the fly. You have to set up that infrastructure and be diligent and rigorous about supporting that product in the field. Do you have a good RMA process? Do you know how to quickly determine whether it's a warranty issue or whether it's another issue? So that's my recommendation, is making sure that just seconding what Jeremy was talking about, ensuring that you have that infrastructure within the business to support product in the field, because it's much different than R&D. And I know that many of us have come from the R&D world and understand that. And there's a strong difference and a level of rigor that gets applied once you move into the product realm.
Thanks, Jorgen. And I mean, as you know, SK is an R&D firm, so that's where we live. But I mean, that makes a lot of sense if you're shipping product en masse, which you are. So,
and there's nothing wrong with R&D, right? If your goal is to be an R&D and push the envelope of what's possible, that's totally fine. You can be, a Carnegie Mellon, creating the next generation of product, right? Or you could be a Boston Dynamics, creating, some really great flipping robot. But talking about near-term impact of solving business need, it's just a different methodology that needs to be applied, which is different than R&D. And both have their place and both have their purpose.
I couldn't agree more. Anyone else want to weigh in? I see some good questions coming in, by the way.
Yeah, if you don't mind, I've got a question
Jen,
here.
take it away.
Yeah, sure. And everyone, if you have questions for the panel, go ahead and submit them in the Q&A tool. We'll go ahead and feed these in and get some exciting answers from these fantastic experts. So we've got a question specifically, it looks like, for Jeremy. Someone wants to know, how do construction workers typically react to Tybott?
Right, it's a good question. As you can imagine, having, so Tybott, which is our first product, is a rebar tying robot working on bridge construction. And for the heavy civil industry, this is the first autonomous robot that's ever been used on a real job site. So you can imagine workers, look at it and think, what do I think about this thing? And should I be scared of it, or should I be happy about it? Should I support it? Should I fight it? Of course, the reactions are all over the place, but in general, the industry has been very supportive of it, because if you think about it, the alternative right now, or the state-of-the-art process of tying rebar on a bridge, is a whole crew of people. Just think about this. It's 10 people bending over, right? Straight bending over, using pliers and a reel of wire, and tying this rebar together, 8 to 12 hours a day, 5 to 7 days a week for sometimes months on ends. So these particular robots, are really alleviating a job that the workers would really rather not do. And specifically when it comes to construction, there are so many other aspects of the job for that worker that they're quite happy to let go of it. The other aspect too, which I think is really fun thing to think about, is that we, for our rental jobs, we send one technician with the robot, right? Because we were very specific in our design process, which I didn't quite get the answer to that question, to not design the robot to do absolutely everything, right? I think we can all, as roboticists, know that there are things that robots can do really well, and then there's things that people can do really, really well. And if you try to have the robot do the part that the person does really, really well, you're kind of wasting your development time. So, our robot can do the work of about 4 to 8 people or more, but we only send one person with it. So it's a gain for the industry. But we have a person we call him a robot supervisor. And I think it's cool because, in this new revolution centered around bringing robotics and artificial intelligence to new types of industries, we're bringing it to construction, and other roboticists are bringing it to other industries. We create a new job position, right? This idea of robot supervisor, I think, is going to be commonplace, just like a mechanic or electrician became commonplace back in the industrial revolution of the 20th century.
Fantastic. Thank you for that. We've got another question here. So this is an interesting one. This could be to anyone on the panel. So what specific challenges do you see while selling your solution into different industries? It's a little more challenging. Who wants to raise their hand and take that one?
I can probably kick this off. So kind of across the consumer industries and let's call it the hard industries. I think one thing that happens is you start realizing that your robot that you first built was probably contextualized for a very specific industry, which you have to really solve their problems. I think that oftentimes, it starts off something like, I'll use an example from the AI world, trying to describe a problem in terms of precision and recall. And quickly, I think you have to decide, how to contextualize it specifically for the business language of that customer. Like, what are the key metrics that they really care about? So for example, in the oil and gas industry, being able to reduce turnarounds, or essentially these periods of where, large vessels and pipes and tanks are offline, being able to reduce that by single days, potentially worth millions of dollars. So measuring, your effectivity against a metric like that is key. In the retail industry, it may be, how are you able to replenish the supply chain? Like, what is the impact of your robot there? In the power industry, it may be something very different in terms of costs and life savings. So I think the idea is, you definitely want to start by solving a very specific problem that you think is repeatable across industries. But the most important part is the customization that it takes. And the customization could be on the robot end, it could be on the software end, or it could just be in terms of business value and how you frame things and solution things together to really enable it to be contextualized for the industry. I think where I see a lot of robotic companies potentially struggling with is where, they get caught in the mystification of how cool the technology is and how does it show up and what the impressions that it makes on the C-suite. And I think those that really succeed in let's call it the B2B space, are ones that can actually begin to connect at a business level. Because at the end of the day, you're typically solving something on the cost side, or you're solving something on the revenue side, right? And in fact, at least the robotic companies that try to focus more on the revenue than the cost, I found generally more successful, although it doesn't have to be true. But I think overall, like contextualizing industry is probably where most people kind of assume that the same ways that they've framed and solved problems in the past will work again. And so I think you really have to go deep with a couple of customers and really understand an industry from the problem side as opposed to the solution side. Falling in love with your technology as opposed to falling in love with the problem.
So I'll jump in to add a little bit to that, which has been one of our main things we wanted to focus on, was having this industry feedback, which is exactly what Vaibhav said, is that we have specifically searched for integration partners in the particular market we're dealing with. Of course, we've started with bridge markets, but we're going to move in to the other markets, such as large buildings and roadways and such. And having integration partners that allow you to define your requirements are essentially vital. I don't think it's optional to be able to design a new robot as a product that's going to work every day without having that particular feedback. That's on the business side, right? But you also need it on the tech side, right? If you kind of got to make a decision early on in your, say, design development process of whether you're shooting to go after essentially multiple types of robots that are similar or one specific one, because if you don't design your software architecture or your design architecture to be, amendable to different types of robots, you're going to end up wasting a lot of effort in trying to go into a new market. So it should be thought about from the tech end, the subject matter expertise end, as well as the business model end.
That's a good way of putting it, Jeremy. And Vaibhav, thank you for interjecting that as well. I know in our experience, when we're trying to wrap our minds around a new industry, we spend a good amount of time studying the customer's business case and trying to understand the economics, because, at the end of the day, like both of you stated, and I can see Jorgen nodding in agreement, if you don't understand the business case, then you're not really providing value. So that's critical. Like you stated, Jeremy, also just creating universal software and hardware systems, and Jorgen is an expert in this, obviously. They can be extended to different environments. That's key to success and scalability. So those are good insights all around.
I think that's an interesting debate that each robotics company needs to have, right? Is of course, if you go too universal, you spend too much time and never achieve your customers' needs, right? But if you go too niche, you're kind of stuck down a particular line. So there's no right answer other than there's a right answer for the particular business and customer base that you're shooting for, right?
Couldn't agree more. So I've got another question coming in from air traffic control, and that is kind of for all the panelists. And this is there a line you won't cross? So is there some kind of system? So for some, it's weapon systems. For others, maybe it might be like nuclear, and anything in between. I don't know. Different people have different reservations about working on different types of projects. Is there anything that you guys just don't want to get involved in as roboticists? I'll open it up to Vaibhav first.
You might be stuck.
Yeah. Sorry. Can you guys hear me now?
Yep. You're back with us.
Okay. Apologies for that. I think that in many ways, like in the software world, when I was working with SAP, there's data privacy was a very big topic, right? And still is. Like there's always companies that choose to be on various lines of data privacy, right? And it becomes such a abstract concept that you forget like what it actually was when you began. I think with robotics, it's kind of a similar way that, there isn't, I don't think that the line is ever super dark in terms of like, this is good and this is bad. But I do think that as anyone who gets in the field, part of the community is trying to find ways to do good in whatever extent possible. I think that a lot of it is, for example, like how do you design safety systems, right? Like that's a microcosm of like, how can you help, with the adoption of robotics and making sure that you build every system to the best of your ability. But I think that from an industry standpoint or, kind of application, I think everyone is obviously different, much like in the software world. But I think it's probably more compelling to think about it as, what level of how are you moving robotics forward as an individual or company, and to take that responsibility,
that.
you know.
Thanks, Vaibhav. Jorgen, you want to take it?
Yeah, for us, it's really easy. You know, our vision is to make the world a safer place through robotics, right? And the way we're doing, and our mission is to develop these intelligent mobile manipulation systems that empower humans to work safely and efficiently, right? So everything that we do and everything that we go after has to align with that vision and mission. If it doesn't, we won't work on it. So it's really our guiding principle and the beacon that we're moving towards at all times. Now, defense was one of our early adopters, but there's a lot of parts, you know, everything we do is to keep a soldier safe, get them away from an IED or from a threat, and to save lives. That's who we are, that's what we're about, and that's what drives us.
Excellent. Those are some good insights there, and an admirable cause as well. Jeremy, what about you?
Certainly, for speaking for our company, we have a very set vision and mission and strategy. So we're going to stick to that, because we got plenty of work to do within the construction industry. Even within where we started to, we're starting first work within reinforced concrete, and I believe concrete's the most used man-made material, period. So we have plenty of time or plenty of avenues to work on within the concrete industry.
Well stated.
Right, but obviously each person has their different opinions of where to go. But I think in general, right, robots have so many different attributes that are beneficial, right? Of course, it's going to save money and make people more productive and more efficient. It helps you save on schedule time. It helps you, just take less risks. But safety is obviously a huge one, right? So I don't think, even if you're not shooting for it, using a robot and removing people from whether it's dangerous situations or even just boring situations, robots are going to have a general good improvement for the overall economy and the world.
Agreed. I mean, and yeah, if you can reduce, repetitive back injuries too, there's so many reasons to get automation involved. Thank you, Jeremy.
So we've got another question came in through the tool here, and keep those questions coming, everyone. We've still got some time, and we've got a nice set of questions here queued up, but we definitely want you to be as interactive as possible. So Spencer, I'm going to give this question to you, actually. Get a little moderator impact, as well as the panel. Let's extend that to the panel as well. This is an interesting one. Simple, but also not. What steps do you follow when you design a prototype? For example, like how much time do you spend on average, and
Sure.
how do you follow that design process?
So that's a bit of an open-ended question. I mean, obviously, but it really depends on how you define a prototype. So if a client wants something to test proof of concept, if they just want to see if something works, often you de-scope and you go for something that's a sort of a simplification of the complete robotic system. So you go for a subsystem first. And again, the time scale on that's impossible to say without knowing what exact sort of system they're looking for. But I can say that, if somebody's in a hurry, that it's a common tactic of ours to negotiate scope down in order to be able to hit their timeline objectives. And so that's one of them. And then for a complete robotic system, I mean, it varies so much depending on the nature of the system and the level of fidelity. And, I mean, we typically aim not to deliver anything to a client that isn't, reliable and pretty bulletproof. So, I mean, if we're going to deliver it, we're going to stand behind it, as I think everyone here is. So that's pretty much our philosophy. I think that answers it adequately. I can't moderate myself. Jeremy, you want to jump in?
So I'll jump in a bit and sort of explain a bit on our philosophy on prototype development. We certainly go through different phases, but for every system, you have a choice to make on whether you bring the particular product to a customer or to the market quicker or slower, right? Which, of course, if you go slower, it's more mature when you get there, but you do a lot of work that's maybe not the right direction you're supposed to go, right? So again, I'll reinforce this feedback from the industry, whether it's the integration partner or whether it's the customer itself, is vitally important. So our approach is to bring a commercial product to market to the customer as quick as possible in order to get that feedback, right? In order to do another round of engineering designs to bring it to the next level of maturity. So I think all of the roboticists on the panel and any roboticist out there will say that, you know, it is not possible for you to create a autonomous robot, specifically a product that's going to work every day, without having that robot work at the job site or in the field a lot, right? You can't anticipate it all. So you have to get that feedback to do the iteration because you just can't do it preemptively. So therefore, how much to do in a prototype? I say do the prototype quicker, get it out there, and then do it again.
It's a good way to look at it. Jorgen, you wanna weigh in on this?
Yeah, I mean, I second it, the comment, it depends, right?
Thank you.
We work on some pretty complex systems, right? You know, we're electromechanical systems that you know, can have 6 degrees of freedom plus a gripper. Sometimes we have 2 arms. Sometimes we have a great foundation. If a customer comes to us saying, hey, we want to create something similar to what you've already done, but we want to optimize it for our solution. So we may have a great foundation to create something quickly, but sometimes you have to go back to the drawing board, and it may take a year to create that prototype. But the key is, you know, going back to what, you know, Jeremy just said, that you have to understand what the true needs are, what the true requirements are, work with the customer, validate early and often, get it out to the field, because what's the laboratory is completely different than the real world. So you have to be out learning by failing, right? You fail early, learn, adapt, modify, and repeat. And you have to do it on a spiral of development, and that's usually the recipe for success that we found.
Amen. Thanks. Vaibhav, you want to weigh in here? I know we're nearing end of time,
Yeah.
but I feel like it'd be interesting to hear your take.
Yeah, can you guys hear me, by the way?
Yeah, you're coming through clear.
It's breaking up again.
Slight latency.
Okay,
thing,
good.
but it seems
Yeah,
resolved.
no, I think that one interest. Yeah, one thing that I think is interesting is, you know, not just from a prototype perspective, but how do you speed up your overall development life cycle? A lot of it is determined by how fast you can make the alpha, which in many cases isn't necessarily to even have a robotic solution. Like if you're looking to solve a problem with accessing imagery data in a difficult place, you know, you can hack a solution together to prove out the business value and then build a robot to achieve the same thing. Obviously, it doesn't work in all industries and all applications, but like I think there's like one hack that I would suggest is like sometimes the robot is a solution that you end up with as a ultimate solution, but there's ways to get there through brute force and technology.
Couldn't agree more. And I mean, I think all of us realize that every situation is different. So thank you, Vaibhav.
I've got another question from the audience here. Just going to chime in here. Got some good ones here. So this one, we've talked a lot about engineering, design, and some of those approaches, which was the focus of today. But I've got a great sales question. So this one is targeted to the specific challenges that you see while selling your solution into different industries. And they gave some examples such as, you know, going from selling into oil and gas, automotive, energy, construction, so many different industries. And how much does the sales cycle differ, you know, from industry to industry, or what changes do you see as you sell into different industries?
I feel like Vaibhav did a really good job starting to address this one. And thank you, John. That's a good question, by the way. The sales cycle piece, I'm just going to weigh in on, and then I'll kick it to the rest of the panel. That can be so different depending on industry. I mean, nuclear seems to have a sales cycle of about 2 years. Typically in the development space, it looks like 6 to 9 months for us from experience. But then COVID, right, threw a wrench in all of that. And so we're seeing projects coming back alive that were on ice for a year. So I guess that's just my little weigh in. Jeremy, why don't you weigh in on this? What do you think?
So I'll frame this and because we're talking about product engineering, so there is a bit of engineering on the sales side as well, in the sense that we are bringing to the construction industry a new product, just as any company brings a new product to the industry, but it's also a product that's never been seen before, and it's an industry, construction robots, that's never been seen before, right? So therefore, the model or the model in which it's advantageous or easily sellable to the industry has to be found out and evolved as well. Is it better to lease? Is it better to sell? Is it, do you lease it for a day or do you lease it for a month? Does your price stay the same throughout the country, or does it change per region, right? So in the same way in which you have requirements and a design process to design an engineering system, you also have to design, experiment, iterate. You're going to have your prototype sales model, and you're going to try that in the industry. And if it succeeds, great. But if it doesn't, you're going to adjust, right? So, I feel for us in the past 3 years of experimenting on how to lease this machine to the industry, we did very similar processes that we did in the engineering realm of trying a particular model, seeing the reaction, and adjusting and adjusting and adjusting, which has been very successful for us. And certainly shout out to my sales team, who led this effort, because I am an engineer, and I love business and I love sales, but those expertise is vital in bringing a new product to a new industry and making sure that your business is an actual business, right? Because in the end, we're a business, not a research and development firm, right?
Sure. I think you mean product company, but yeah, I agree with you on that. And that's very important. Those are good insights. Jorgen, Vaibhav, you want to weigh in on this one as well?
So we developed these intelligent mobile manipulators, and they're generic solutions that can be applied across different markets. So we serve the medical industry. We're making surgical robotic arms. We are serving defense, to keep soldiers safe. We're dealing with aviation, helping with inspection and maintenance. We're in the energy market, helping to install solar fields during construction of solar fields. And each one of them has a different tempo and a different rate of adoption. And the way that we typically operate, the fact that we have this generic solution, rarely when we identify a need, can we just take exactly what we have and apply it? They're usually, going back to my original point of understand the market need and optimize for that problem. So then we reach into our toolbox and we take something that foundationally solves the problem, and then we begin optimizing it. And that can take a year, that can take 2 years, sometimes it can take 3 years to optimize it to the level of reliability and quality that market deserves. Robotics is not a fast sales cycle, right? Especially field robotics, to get it right, it takes years of development and rigor to get it to the maturation level needed.
It's a beautiful insight. Thank you, Jorgen. How about you, Vaibhav? Do you have anything to weigh in here?
No, I think covered.
Yeah, fair. I mean, you had some pretty good insights earlier on.
I just add that, I think part of the solution is bringing the engineers.
I think we've got time for one more question. We've got here a question focused on hazardous locations. So what are each of your ambitions for robotics uses in hazardous locations? Do you have any experience? This particular individual said they built a few and that was a real adventure. So anyone want to answer that?
Well, we shipped some to Fukushima. pretty hazardous.
I think I saw a class 1 div 1 in the text over there. So they were talking about X-proof.
Yeah, no, those are areas, since we serve the aviation market, and we're going to be looking, and we are going to be looking at automated refueling and other tasks like that. You need to look at those type of certifications. So Those are areas, whether we like it or not, we're going to have to become experts in. I won't claim that we're experts in those areas yet, but best way to become an expert. That's right. We'll learn it as we go, but that will become part of our world because the markets that we serve have some of those requirements.
It's a great way to put it. Thanks. Jeremy, do you have any thoughts on this one?
So we don't go into any radiation fields, although my prior life was a submarine officer operating a submarine reactor, so I'm very familiar with those realms. But I'll use it to sort of reiterate the idea of safety. Of course, these robots are meant to work side by side with people and other workers there. So the idea of taking safety seriously, evaluating it, and mitigating the risks are certainly important. But again, in the end, even on a construction site, you are using robots to take humans out of situations that are less safe, or in the case of Fukushima, absolutely not possible to go into.
Sure, that's a good insight. Vaibhav, is there anything you want to weigh in? Obviously, Gecko has probably a horse in this race, so it'd be interesting to hear. And then I see Joel getting ready to close us out. So.
We may have lost him on the audio. Spencer, I think we lost him.
That's unfortunate. I think we just have to go forward then. Do you want to take it from here?
Yeah, Spencer, thank you very much. And really enjoyed the conversation. I got to tell you, I always love it when world leading engineers tend to talk more about business topics than about the engineering and robotics parts. That is a really good sign for our industry. Some takeaways that I had, especially along those lines: find the problem, find the need, and then optimize the solution around it. We had a great conversation about focusing on customers and business cases, metrics, and the economics. And I also thought there was a really good comment, I think from you, Jorgen, about planning for safety and quality and making that a well-defined process for the business. In advanced robotics, we're building beyond industrial robots. We're moving around in these unstructured environments. Most of us have been coming from R&D. We're still at the very, very early stage. But when you start deploying those products in the field, I think Jeremy alluded to this, we just become a business. And you have to start focusing on all of those aspects. So I think that's a real great takeaway for this. And it's important to know and stick to your mission. Find out what your focus market is, focus on that customer, focus on those business cases and finding that success. A lot of good engineering that's necessary, a lot of challenges and problems that have to be solved. But at the end of the day, we're focusing on someone's issue or problem and looking to improve upon that and putting viable solutions into the marketplace. I want to thank everybody here on the panel. Would like to thank you, Spencer. Really appreciate you and SKA supporting the PRN and organizing a vitally important topic. I really do encourage the audience to learn more about SKA and reach out to Spencer. To our panelists, Jeremy, Jorgen, Vaibhav, thank you very much. I really appreciate your time and sharing some of those stories. By the way, I have a quick story I wanted to add, which is on the sales side. I was driving a robot around for early demos in a 20-foot straight truck, and I ran into a bridge trestle. So the important lesson there is do not have your salespeople be doing your transportation as well. You can't be doing two things at once. And if anybody wants to hear more about that story, I'd like to tell you personally. I also want to recognize, you heard the voice. We didn't get the chance to see her, but Jen Apicella, who has joined the PRN just recently, I thank her for all her help in putting together a program that's going to be coming out this year. and working with our sponsors and our panelists to set this up. I'm very excited to have her join the PRN community. So again, another reminder that we have an event coming up on Tuesday, May 25th, featuring Jim Rock, who's the Chief Executive Officer of Seagrid Corporation, being interviewed by Tim Chipetta, who's a VP of Business Development at BAE Sensors. That promises to be a really good one. And I do encourage you to get involved with us in our community. If you have any questions, you can follow us at robopgh.org, sign up for our newsletter, or you can email us directly at info@robopgh.org. This webinar was recorded. It will be made available so you can see it after. And then finally, I'll just say, we'd like to give people some more time to fill out the form. It wasn't available at the outset of the event. So we will email all of our participants. And if you'd still like to participate in the prize giveaway, you'll have the opportunity to do so. And then we will select a winner from that. So please do follow that link or look for the email. Thanks again to everybody. Thanks for a great turnout, and wishing everybody a productive rest of your day. Take care. Thank you.